Hey guys, today we're gonna solve this integral, but without using trig. We're gonna solve it with imaginary numbers. So as you can see, this integral would usually equal to arctan of x plus a constant c. But in this case, we're gonna play a little bit. We're gonna assume that we don't know what really trigonometry is, and we're gonna use imaginary numbers. So as you can see, the right thing to do is to set the domain of the equation not equal to a real number. This is really important for any math course that you're taking, especially if this is advanced. So the first thing that I'm going to do is to factor the denominator, which is going to give us x plus I times x minus I. And now you're going to see that it is perfectly going to cancel out and give us x squared plus 1. All the terms perfectly canceled out, so basically now we're going to equal this to an integral, but with factored terms. So we're going to have one term in the denominator plus another term in a different denominator. So when they multiply out, they give you the partial fraction that you're looking at the beginning. I'm gonna set the first term as a over x plus I, and the second one is b over x minus 1. The constants can be a, b, c, d, it really doesn't matter. And I'm gonna just multiply it out, just do a little bit of fun algebra right here and set it equal to the original numerator that was 1 of the original function. The original function being 1 over x squared plus 1. And now this is basically just algebra. We just are gonna solve for a and b as the constants, so we can rewrite the integral in just a polynomial way. Here we can see that a and b are the negatives of each other. That is pretty interesting and has to do a lot with harmonic motion. Honestly, this has really interesting applications in engineering and many transformations, but in pure math it is fun too. It just shows how we can approach the same problem in many different perspectives. And yeah, I'm just rewriting this with the coefficient terms that we found being a and b. I'm just setting 1 over 2i to the side so it's easier to integrate, but you guys can do it whatever you want. You can use a u substitution. I'm doing it because it's easier, and we just figured out that they're really easy to integrate. Now we can simplify and just taking common terms, which is 1 over 2i, and then just using the logarithm laws to make it as a fraction, and we can just equal that to arctangent. Then we can solve for the constant. The constant, if I'm not wrong, is 2 pi. It is really interesting to solve for it. This integral is so interesting because it brings so many theories of math together. Even when you're solving for the constant, it brings the perfect equation, which is e to the power of I times pi equals to -1. you will need to know that to solve for the constant. And yeah, it is basically really interesting. I feel like it brings a lot of topics together and it makes it easier to understand, as well as it has many applications in real life.